We use a scatter graph to investigate correlation between two variables. Basically, if we want to see how changing one variable might affect another variable, we use a scatter graph. Here's an example. The scatter diagram shows the height and mass of 10 dogs. These dogs are all West Highland Terriers. Draw a line of best fit on the scatter diagram. When drawing a line of best fit, we basically want a line that goes through the middle of the points. So it obviously doesn't have to go through all of the points, but it should go through the middle of the points to show the trend. So roughly, you're going to want to have equal number of points either side of the line. So maybe like that. And also, if you're given the mean point, so if you're given the mean x coordinate and mean y coordinate, it should also go through that. So this is our line of best fit, and we want to describe the correlation between height and mass. Well, as height increases, mass increases, according to the graph. We call this positive correlation. So if as one variable increases, so does the other, we call that positive correlation. And for C, we want to use our line of best fit to estimate the mass of a West Highland Terrier that has a height of 26.7 centimetres. To do this, I'm going to go across to 26.7. So let's have a look at the scale. So it's gone up in 0.1s. Yeah, it's gone up in 0.1s. 26.7 is here. And what I do then, I draw a straight line up from there. And then I draw a straight line across from where the line I just drew hits my line of best fit. So there. Right, and reading that, because it's going up in 0.2s, 4 to 5 in 5 units means it's going up in 0.2s. So if I read this, this is 2, 4, 6, that's about 7.8. Maybe you could say 7.9. So I'm going to say 7.8 kilograms. Finally, in D, another dog has a mass of 8.2 kilograms and a height of 35 centimeters. Is it likely to be a West Highland Terrier? Well, if we go across from 8.2 kilograms, here we go, and we hit our line of best fit, and we go down, this will give us an estimate for the kind of height we could expect for West Highland Terrier, which weighs 8.2 kilograms. So, right, if we now go down from there, right, and if we do that, that gives us 27.6 centimeters, which is quite a lot less than the 35 centimeters. So I would say the dog is unlikely to be a West Highland Terrier. Here's another example of a scatter graph. A restaurant manager plots a scatter graph showing the temperature in degrees C at 9 AM and the number of hot drinks sold during the first hour on each of 10 days. Now you can think about this sensibly. If the weather's hotter, people are less likely to buy hot drinks. But it's important to note, though, that these graphs don't show what we call causation. It doesn't tell us straight away that an increase in temperature tells us that this causes fewer drinks to be sold. It just shows the relationship. First of all, let's draw the line of best fit on this scatter graph. So again, I want my line to go through the center of the points, approximately the same number of points either side of the line. Okay, so approximately like that. Okay, so we want to then estimate the number of hot drinks the cafe will sell when the temperature is 6 degrees C. So I'm going to go across to 6 degrees C. which is here. And I'm going to draw a straight line up from there. And then where that line hits line of best fit, I'm going to draw a straight line across. Like that. Okay, so I can see that it's going up in twos, so that is about 31 hot drinks. Describe the correlation between temperature and number of hot drinks sold. Well, this time as temperature increases, the number of hot drinks sold seems to decrease, and we call this type of correlation negative correlation. For question E, they want us to comment on the suitability of the graph for estimating the number of hot drinks sold when the temperature is more than 17 degrees C. And I would say immediately that the graph is not suitable for that, because that is well outside of the range of temperature values that we know. We're only given data up to about 8 or up to about 7.5 degrees C. So this is well outside of the range of data that we have. Finally, you might see a graph like this, where your x variable and your y variable don't seem to be related in any way. So as I increase x, there's no consistent increase or decrease in y. We call this no correlation, and it means that we really can't get much from the data.